Hey, Mr. Herdum here. We're going to go over some history of the periodic table in a bit here. But here, this page right here says property of selected groups at the conclusion of the periodic challenge. So you will fill out these notes in class after periodic challenge. That is when page 3 will get filled out. So I'm not going to discuss page 3 right now. I'm going to move on to page 4. Page 4. Okay. Video of alkali metal reactivity. You can check out that video here to see how well alkali metals react. Okay. Something to think about. Groups 3 through 12, those are the transition metals. You're going to also I'm going to refer to these as D block elements later on. I'll get more into that later on. But based on the facts that they're metals, make some predictions on the properties of these elements. Metals are mostly silver and gray. Do they have luster? Yes. Metals are shiny. Do they conduct electricity? Yes. Elements like copper are very good for conducting electricity, gold, and silver. Malleable and ductile. Can you beat it with a hammer? Can you make it into wires? The answer is yes. Okay. And melting points and boiling points. These would have high melting and boiling points since they are metals. Okay. These also make very colorful compounds. Okay. It's a little bit about the transition metals. Maybe I'll have some time and I'll do a demo where you can actually see the different transitions of the different colorful compounds of the transition metals. Okay, so where did the periodic table come from in the first place? Okay, again, we have a couple videos you can watch here for the puzzle of the periodic table and the genius of Mendeleev periodic table. Okay, Mendeleev was the first person who came up with the periodic table. He is a Russian superstar, and he has an awesome beard. He arranged the table by atomic mass. He was able to keep elements with similar properties grouped together, just like he did in the periodic challenge. And Weisweiss may add blanks for unknown elements. All the elements were discovered at that time, and he would predict that they would be discovered based off of the properties, right? And he actually has an element named after him too, number 101, Mendelevium. Okay? So he came up with the first periodic table. Okay, then there was Henry Moseley. He is from England apparently. Okay, I think he died in World War One. I think it's kind of sad. He came up with the modern periodic table. Okay. Now, he found out that the elements were not arranged by atomic mass because, like argon and potassium, do not go in order of atomic mass. So he arranged them by atomic number. Atomic number is the number of protons, which we'll go over later as well. Okay. And he did this with X-ray spectroscopy and all that fun stuff. Okay. So big thing here. Mendeleev first periodic table had undiscovered elements and arranged it by atomic mass. Henry Moseley did the modern periodic table by the number of protons, which is the atomic number. Okay. Moving on. The history of atomic theory. Okay. first thing here. The smallest particle matter which exhibits the properties of the element is an atom. Okay? It can be broken down to smaller parts, protons, neutrons, and electrons. We'll get into that in a little bit. But you cannot tell the proton of a gold atom from a proton of an oxygen atom. Atoms are very small, 1 times 10 to the negative 8 centimeters in diameter. Okay? And here's a video to talk about how small atoms are. So let's discuss the theory and the history of the atom. Coming up with the models of the atom. Okay? And there were 5 main guys that did the models of the atom. Okay? Some technology comes out and we discover new models of the atom, blah, 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 blah. And the first person that came up with a model of the atom was John Dalton. What he said was atoms exist, pretty much. Okay? He came up and said he had the billiard ball. You guys know what a billiard ball is? It's like a pool ball. You know, you play pool and you go like that? Yeah. Yeah. He came up with the billiard ball theory of the atom. Okay? When you draw the model of the billiard bottle atom, it is just a sphere. There's nothing in it. Okay? No protons, no neutrons, no electrons, nothing. He just said that they existed. And Dalton came up with the first atomic theory. Okay? And there are 5 parts of this atomic theory. Okay? He proposed that all elements are composed of very small particles called atoms, which are indivisible. He said that you cannot split atoms. Okay? So the first part of his theory was wrong. We know today that protons, electrons, and neutrons are parts of the atoms. Dalton didn't know about protons, that's a symbol for proton, neutrons, and electrons. Okay? He just said there was an atom, and that was it. Okay? So he's doing great on this atomic theory. He came up with a wrong thing first. Second one, he said that all atoms of the same element are identical. He was wrong again. There is this term called isotopes. Okay? Isotopes have the same number of protons, but different number of neutrons. Okay? He did not realize that atoms had different masses. Same atoms can have different masses. John Dalton did not realize that at all. Okay? So he's wrong twice already. Good atomic theory here, he's wrong twice. Okay, number 3. Atoms of different elements are different. This is actually correct, which is right. An atom of lithium is different from an atom of helium. Okay? They have different chemical properties and all that stuff. So, good job, John Dalton. Atoms of different elements can combine with each other in simple whole number ratios to form compounds. Guess what? He was right about that too. You can combine 2 hydrogens with 1 oxygen and make water. That's basically what he was saying there. Okay? Chemical reactions occur when atoms are separated, joined, or arranged. However, atoms of one element are not changed into atoms of a different element by chemical reactions. Only nuclear reactions, which are different. He was right about this one too. You can join the atoms together to make something new, make a new compound. You can You can break up the atoms to make from a compound to an atom, or you can rearrange them as well. Okay, and get a different substance. So just write 3 out of 5 times. So not bad. Okay. Then we get to my homie. This is my homie. Did you know this guy's my homie? I refer to him as my homie. J.J. Thomson. He gets credit for discovering the electron. Okay? He did this in the cathode ray tube experiment. He proposed that electrons are negatively charged in the atom, where he was correct about this as well. So I'm going to write down right. Okay? So how the cathode ray tube experiment existed here. Okay? So he took some particles and he shot them through the cathode ray tube. Now cathode ray tubes, they're hard to find anymore. They used to be in those old big box TVs kind of things and stuff. Yeah, we don't have those big box TVs anymore. Now we got those flat screen things. But yeah, there used to be cathode ray tubes. And there used to be a magnetic field that this side was positive and this side was negative. And during this experiment, when he was using these, I think it was using metals at the time. Yeah. Okay. He saw when he shot a beam of light through it here, he saw it start to bend like this towards the positive. He understood that positive and negative charges attract, and so this is how he discovered the electron. Okay? And there's some videos showing his experiment here that you can watch if you have time. Moving on to page 6. Page 6. So the model that Thomson conceived of was the plum pudding model. Now you must be asking me, Mr. Harridan, who eats plum pudding? Apparently English people do. Okay? So, in the plum pudding model here, he said that electrons were swimming in the pudding that was positively charged. Okay? He was wrong about this. This is not the correct theory. So here, in this model here, we have an electrons. These are negatively charged particles. And this is positively charged material in the middle. Okay? That is the plum pudding model right there. Okay. Moving on to the third guy. Gotta go through 5 of these guys. Ernest Rutherford. Hey, did you know Ernest Rutherford was Lord Ernest Rutherford? Yeah. They made him a lord. They did the thing with the swords and all that fun stuff. Yeah. Okay? He proposed that the atom was mostly empty space and that all the positive charge was located in the central nucleus, which is correct, which he was right about. Okay? Here is a video that you can watch to see the Gold 4 experiment. Here's basically what happened in this. So these are alpha particles that are going to come out here. Okay? And he was expecting, when he shot these alpha particles at the gold foil, that he wanted them all to go here. He was expecting all of them to go here. But what actually happened is some of them went over here and reflected, some of them reflected here, and some of them reflected here. Okay? Which told him that this was actually hitting something which must have been in the center of the atom to make these reflect. Okay? But most of them beams went straight through, indicating that the atom was mostly empty space. Okay? So like it says here, they were deflected. Some were deflected back and missed the fluorescent screen. Okay? Reason, positive alpha particles were hitting something small, positive dense nucleus and getting deflected. Since positive and positive repel. Okay? Conclusions here. There is a dense positive nucleus, meaning that the plum pudding model was incorrect. Electrons are moving around the nucleus, and the atom is mostly empty space. So when you look at the Rutherford model here, you have a nucleus in the center, you have these electrons that are around, and the atom is mostly empty space. So this is the Rutherford model right there. So Thomson basically discovered the electrons. While Rutherford discovered the nucleus positive, meaning the atom has protons. Okay. Which points did Thomson and Rutherford prove wrong? He proved that the atom is indivisible. I can't spell indivisible. Was wrong because of these smaller particles. Okay, give you a second to look at that and write that down. Right. Try to keep it on the screen, Mr. Harridan. Try. Okay. Two more guys to do here. Then we got Niels Bohr. He was Dutch. No, he wasn't. He was Danish, Mr. Harridan. Come on. Mr. Harridan, you need to study your history more for chemistry people. Okay? He was working with Thomson and Rutherford and came up with his own atomic model. This is model number 4. Rutherford was 3. Thomson was 2. And Dalton was number 1. Okay? He proposed that electron at an energy levels in an experiment with atomic spectrums. Ooh, good for him. The further the electrons from the nucleus, the higher the energy. This is actually correct. He proposed a planetary model of the atom in which the electrons orbit the nucleus like planets of the sun. He was wrong about that. Okay, so this is probably the model that you know from middle school here. You have protons and neutrons that are positive in the center. Okay, you have electrons in orbits that go around the atom. And yeah, that's why they call it the planetary atom, because the electrons go in orbits around the atoms. Okay? Again, this is not the correct one here, but this is the planetary model. Now we need to get to the 5th and final model, and the current model that we use today. Now we go to Ernest Schrödinger, who is from Austria, okay, who worked with Heisenberg apparently, and de Broglie. In his research, he did quantum mechanical wave model of the atom. Okay, so basically what he did was a lot of math. Okay, and he came up with the current model of the atom that we have today. He does not use the orbits. Ernest Schrödinger said that the electrons are in orbitals. An orbital is a space where you're most likely to find an electron. Okay? This is where you find the electron 90% of the time. Okay? So in his model here, I better get a pen to do this here. Don't want to ruin one of my good pens here. So in his model, he had the nucleus in the center. Okay? And electrons basically jump around from space to space. Like this, jump around, get up, get down, jump, 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 jump. And then he gave this overall area here where the electron was found 90% of the time. That was the orbital. Okay, which is different than an orbit, which we'll get more into in the next unit. Okay? You guys are champions. The legend is